Great. So this next unit, we're going to be looking at the study of what we call quadratics. And quadratics, as it's spelled up here, is nothing more than those U-shaped figures we also call parabolas. So how do you know it's a quadratic? What you want to do is you want to look at your equation over here, and you want to look for the highest power. So obviously over here, the highest power is 2. So if the highest power is 2 with your x's, you know it's going to be a quadratic, or it's going to be a parabola when you graph it. So let's talk about how you graph quadratics. It's simply you need to set up a table like this, and hopefully what's going to happen here is I chose these values on purpose, 1 through 7, because I happen to know where the vertex of the parabola is going to be. However, sometimes you have to guess a little bit, and later in the unit we'll discuss how to figure out exactly where that is. But for now, let's just use these values 1 through 7. So what you're going to do is you're going to plug in these values into the equation here. So if I were to plug in a 1, 1 squared would be 1. Minus 8, or negative 8 times 1 would be negative 8. And then finally plus 15. So 1 minus 8 is negative 7. Plus that would end up being 8. And then we plug in a 2, for instance. So 2 squared would be 4. And then we take negative 8 times 2. That would be negative 16. And then we finally add on 15. And so we end up getting 3. So you just repeat the process over and over again. If I were to plug in a 3, you would get a 0. If I were to plug in a 4, you would get a negative 1. A 5 would be a 0. We have 6 would be 3. And finally, we have 7 would be 8. And what you should notice is, as you do this, is that you'll notice a pattern. And that is, you'll see right here, let me change colors here. You get the same values here for our y. Same thing over here, 3 and 3, and then 8 and 8. So you'll notice that the same y values will repeat itself, and in the middle is our vertex. So I'm going to go ahead and graph these here. So we have 4, negative 1, 1, 2, 3, 4. Here's negative 1. Then if I were to go over here, let's see, I would have, let's see, 3 comma 0 would be here, 5 comma 0 would be over here. So so far I've graphed these 3 points. I'm going to go ahead and graph 6 comma 3. There's 6, 1, 2, 3. Also, I've got 2 comma 3, so 2 comma 3 is right here. And then finally, I've got 7 comma 8, and I've got 1 comma 8. So you'll notice here, here's our U-shape figure over here. And then we go ahead and we graph it by, now we never use a ruler, we always use our straight hand here. So do the best you can here. So I'm going to do the best I can going through all these points here. It's going to be curved at the bottom. So remember, it's going to be a U-shaped figure. I'm going to come back around. And then, of course, go ahead and put arrows on the end. So that's our parabola right there. And there's some things here that are going to be very important here to notice. First of all, this kind of parabola is going to have its vertex as its minimum point. So we call this a minimum. And when we do that, our vertex here is going to be, in this case here, 4, negative 1. So over here, I'm going to write down some distinguishing features of this quadratic. First of all, our vertex is 4, negative 1. Super important point. Also, some other things that come into play are, this is our x-axis over here. We have 2 x-intercepts in this case here. So I'm going to write x-ints, and we know those coordinates, 3 comma 0, and also 5 comma 0. So we have 2 of them in this case here, although we don't always have to have 2. We'll discuss that more in a moment here, but in this case we have 2 of them. Also, if we were to continue up over here, what would be our y-intercept? Now, it's not going to show up on the graph, but that's okay. But basically, a y-intercept means we plug in a 0 and see what we get. So if we plug in a 0 over here, 0 minus 0 plus 15, it would be 0 comma 15. So these will be some distinguishing features about this actual graph here. Finally, you'll notice here, as I was talking earlier, the same y values show up here. So what this really does is it creates, if I were to draw a vertical line like this, straight through here, here's my vertical line, I'll make it dotted in this case here. If I were to draw this vertical line, this line becomes what we call a line of symmetry, in that I could fold over this part of the curve and it would fold over this line exactly onto here. So this line of symmetry would have an equation. And what you should notice is it doesn't matter what point I pick, whether I pick a point way up here, by the way, that coordinate is 4 comma 9, or if I pick a pit, let's see, this point right over here, this would be 4 comma 1, 2, 3, 4, 5, 6. This would be 4 comma negative 6. It doesn't matter what point I pick on this line, it's always going to have an x coordinate of 4. So our line of symmetry is going to be x equals some number, and in this case it's 4. And what you should also notice is this matches up with the vertex x. So whatever the vertex is, the x-coordinate tells you what your line of symmetry is going to be. So those are really the distinguishing features here on any sort of parabola that we make. We want to always talk about the vertex, the x-intercepts, also the y-intercept. That would be very helpful, as well as the line of symmetry. Also in this case, we have two x-intercepts. We don't necessarily have to always have two. For instance, we could have our vertex actually on the x-axis itself, and maybe it's going down instead. So that would be a case where we actually have one x-intercept. We also might have something like this, where our vertex is up here, it's going up. In this case, we have no x-intercepts. And by the way, anytime we have a parabola that's going down like this, where this point ends up being in a max value or a max point for our vertex, what happens is that basically over here in our equation, what will be different is there'll be a negative in front of the x squared. So if you have a negative value, a negative coefficient for x squared, we're going to have a upside down parabola, and if it's a positive number, in this case it's positive 1, it's going to be heading up. So that's what you need to know about graphing parabolas.